Okay, so far you have taken fraction functions, which this is the most basic of your fraction functions, y equals 1 over x, and you just added fractions together. But do you remember, I mentioned this yesterday, what that function kind of looks like? Sketch it quick if you remember what that function looks like, because that's what it's going to be all about soon, is this parent function. Now, I showed you how to find points on the XY chart, and you could make a bunch of dots, but these two are the most important ones. And then this is your line that gets really, really close to the X and the Y axis. Why does it get so close? Because there's something there called asymptotes. These dotted lines that run across here and here are vertical and horizontal asymptotes. Now, do you remember when we took functions and when we would like add 3 to it, the whole function would move where? Up 3. What if I put a little like -1 down in there with the x? That's not going to move it up or down 1. That's going to move it what? So the whole thing would move right 1 and what? Up 3. Now, it's hard to do unless you've got a little lasso tool on your keyboard, which some of you guys do. And if you grab just the little part that, ooh, sneaky. I've never seen somebody do it like that before. That's a good idea. She looped around, and I don't have a lasso tool on mine, but she looped around and grabbed this and then grabbed that with the lasso tool, and then she was able to move the whole thing. That's a good idea. Right 1 and up 3. Okay, so anyway, just a quick reminder that those are called asymptotes. You get closer and closer to them, but you never touch them. And I think that's enough of the looking into the future. Instead, let's spend some more time talking about what happens when you have something cancel like this. Everybody factor it. If you can factor it, you should. Factor it, and then you cancel stuff, and then I want to make sure you understand what it leaves behind. It leaves behind some residue, some proof. It's kind of like a good detective would be able to tell that something had happened. Well, once you factor that, you should have x plus 2 on top, and then a x plus 2 and an x minus 2 on the bottom. But when this cancels, a lot of kids just cancel it, and then they say the answer is x minus 2. Nope. Nope. What is the answer? 1 over x minus 2. When things cancel like that, they're really leaving behind a 1 and a 1. Now, this 1 times x minus 2 on the bottom isn't really necessary, but if there's going to be nothing left, then a 1 is really necessary, very important. Okay, and that creates a hole in the graph. When something like that cancels, that creates a hole. You've never seen this before. You've always had graphs. You've never even had asymptotes, but now you understand that when there's an asymptote involved, it'll get really, really close to that. But what if there's a hole? Well, then I'm going to show you with my little erase tool. If there was meant to be a hole in the graph right there, then that means the graph just has an empty spot right there. And then it just keeps going as if nothing happened. That's very different than an asymptote. This is called a discontinuity. Fancy word. Do you get that's a spot where the function does not just continue through it? It does not continue. That's discontinue. So this is a discontinuity. Okay. Anyway, that is a hole in a graph. And you've never seen one until now? Yay, I get to be the first one to show you. All right. What was it, asymptote again? Asymptotes were when you have a dotted line like this, and maybe even another, oftentimes there's 2 in these, dotted line, and then your function can't cross that, but it has to get close in the long run. So if I know it goes through this spot, then I know it has to get closer and closer and closer and closer this way. So if it has to go through this spot, then it has to get closer and closer. Kind of helps you to draw it if you know that the function is going to be drawn to the asymptote, just like a moth to the flame. That's particularly poignant because a moth will actually fly into the flame and hurt itself because it's so attracted to that thing. And so that's why that analogy gets used a lot. In this case, does it actually hit the flame? No. It gets really, really close, never touches it. I gave the example of a pool the other day. And let's say that you dumped a glass full of, let's just call it black ink. Do you get that it would spread out in the pool and it would be kind of gross? Well, if you took out, let's say you took out half the water in the pool and replaced it with fresh water, would it make it better? Yes. Would it make it all go away? No. If you just took out half the pool's water, kept doing that, it'd get cleaner and cleaner and cleaner, but it wouldn't ever get all of it, ever. It would get infinitely close, but it would never actually clear out all of it. Now, other things that get really, really close but never actually happen. I'm sure you've been in the room when somebody's ripped one. Well, that fart is in the air. You can't help but breathe it. You're going to be breathing it because it's going to spread out in the air in the room, and you're going to have that in your lungs. It's true. And, well, what if you take that to the extreme, dinosaurs were farting for a long time before we were ever here. You're breathing dinosaur farts right now. It's true. They don't just like drop out. Okay, it's in there. All right. So anyway, it gets closer and closer to perfectly clean. The cleanest air on Earth is in Hawaii. And we own that. Yay! The United States has the cleanest air anywhere, and it's because it's on the tip of an island, Hawaii, where the air has, because of where wind currents usually come from and stuff, has been blowing over the ocean for the longest period of time. And that air is statistically the cleanest air on Earth. Isn't that interesting? So, and it's in the Hawaiian Islands. All right, anyway, let's get back to what were we doing. I'm going to give you a typical question for today that reviews yesterday's stuff. If you had x over x plus 2 and you had to add 1 over 2, I tried to show you yesterday how you could not just add x to the top and the bottom. That is not legal. That would seem like it would give you a common denominator, but you're cheating because you can't add something to the top and the bottom of a fraction. So that won't work. I'll give you the example I gave the other day. Let's say I had 4 over 5, and then I add something to the top and the bottom. 2 and 2, is that the same as 6 over 7? No, 4/5 is not the same as 6/7. It's different. Now, could I times by something on the top and the bottom? Yes, I could. So that's what you should do, is you should do a multiply by, and I would say yesterday always, multiply by the other denominator. So go ahead and do that. Oh, interesting. Never thought of that. But that would make me Sal. Sal's really, really, really smart. Not saying he's always got the best explanations, but he's really smart. He's got degrees from like Harvard and I don't know, some other big time school, and he knows a lot about not just math. So his videos go deep into really complicated concepts. So I do respect what he was doing. But you guys have heard of Khan Academy, right? Back when he did Khan Academy, I was making my own thing, and we made 1,000 little 2-minute videos, so I called it 2-Minute Teacher. But he went with a different model than I did. He went with put all his videos at Khan Academy, made them completely free, and I didn't put them out and make them completely free. And then his completely free thing got Bill Gates' attention, who's a super rich guy. And so he said, how about if I give you $1 million, could you make the site even cooler? And so he was like, yeah, I could. So anyway, yes, that's why you now know about Khan Academy, but you don't know about 2-Minute Teacher as much. Anyway, you may have heard of it, but. Okay, so anyway, my little 2-minute videos on math were kind of cool, and I kind of like what I did too, because I hired people to teach the elementary grade stuff because I knew I couldn't do a great job at it. You would think, like adding, like, well, I can teach people how to add. But actually, it's a skill to go to a really low level like that and help people understand it for the first time. You know what I mean? You might think it's easy because you know how to do it. That doesn't necessarily mean you know how to explain it best. And I realized after watching some of the videos, dang, they have some really good ideas on how to teach people simple stuff like adding or how to tell time. And I learned a lot by watching those teachers teach those lower level skills. All right, so I hope you multiplied this by the other denominator, which is 2 here. And notice you're always multiplying by 1, really. And then x plus 2 here and x plus 2 here. And why is that okay? Because you're multiplying by 1. So then I suggest that you not multiply it out on the bottom. It's very common for people to say 2x plus 4 on the bottom. Don't. Why? Because if you can factor it, you should. But is that just because I really like factoring? No. It's because things will cancel. So I got 2x here, and I got x plus 2 there, and I can combine things that are alike. What I could not do is say, change that to 2x times x plus 2. No, that's not legal, because what's on top? That's a plus. That's a plus right there. So this is 2x plus x plus 2. And then I can put that all together and say 3x plus 2 over 2 parentheses x plus 2. And can I factor any more? No. So then I can tell that there's nothing that would cancel. All right, let me give you an example of an answer that hasn't been finished yet. Do you get some kid writes this and gets it marked wrong? Do you get how if they would have factored it further, something would have canceled? All right, so you don't have to write this, but I think you know, you see what would have happened. Oh, cancels. And that's a big deal to not cancel that. So final answer 2. All right, so what are you doing today? It is so easy. All you got to do is add and subtract. No, that was yesterday. Multiply and divide fractions. And why is that better? Because you don't need common denominators. It's so much easier. The only thing you got to do is handle things where there's a lot of canceling. It's like, so for instance, let's say for you had this one, x squared plus 6x plus 5 over x squared minus 25 times x plus 2 over x, let me think. And then, okay, there we go, I got it. Plus 1. Now, could you multiply all the way across the top? Yes, but it wouldn't be very smart. Do you get that this would be a really complicated answer when you have to multiply out all 6 parts of it? Why would it be better to do something else first? Because you could do something that would make stuff cancel, and then the problem will be so much simpler. So let's not just multiply that all out. Even though we don't need the common denominator, and we could multiply it all out, there's a much smarter thing to do. If you can factor it, you should. So you get the thing factored here and here, and then you'll see a whole bunch of stuff will drop out or cancel out. And when it's canceling, it's really changing into 1 over 1. All right, so what does that top one factor to? You should have said x plus 5 and x plus 1, and hope by now that's just pretty much automatic. This one's x plus 5 and x minus 5. In either order, it doesn't matter. And then those will cancel. Just remember, if it matters, which sometimes it does, sometimes it doesn't, they leave behind a 1 over 1. And then do you see other stuff that cancels? I see something else that cancels. What? That one and that one. Final answer? X plus 2 over x minus 5. Make sense? All right. Now, later in this unit, we would say, now graph it. And you'd be like, oh, crap, this one's complicated. If it didn't have this 2 or this x, it wouldn't be that bad. If there was like a 1 there, it's a butterfly, except shifted 5 to the right. But it's got this other stuff. How am I supposed to graph that? Well, people always get stuck on graphing, and I always remind them, what's their best friend on graphing? XY chart. So if you had to graph this one, you don't have to, but if you did, you'd want to make an XY chart. And then you just go, okay, if y equals all that, then I'm going to put in any number I want. What number should you not pick because it'll make your life complicated?
0.
Actually, 0 works in this case, but I know what you mean. You don't want to make the bottom 0. But if I put in a 0, that won't be a problem. But what could I put in that would be a problem? 5. So 5 is a number you would not want to pick because it makes the function have a 5 minus 5, which is a 0 on the bottom, and that's not good. All right, so you would now not put in 5. Actually, when you do put in 5, it gives you an asymptote. When it fails, think about either it's a hole or it's an asymptote. Okay, enough about that. That's, again, previewing into the future. Just, I know that when we get there, those are the tough days. This is an easy one. So we had time to kind of, I'm going to change colors. Now I got the classic green blackboard. I'll write in yellow chalk. All right, you ready for this? Let me think. I'm making this a divided by. There. It's perfect. When you get it flipped in the right places and factored in the right places, a whole bunch of things cancel, and then you'll just have a nice, clean answer with things on the top and the bottom. Give this one a try without any help from me. And I'll pause for a moment and see how you do. Okay, you should have factored it this way. X minus 5, x plus 1. If you're like, wait, I did it a different way. Well, you can double check yourself. X squared plus an x minus a 5x makes negative 4x. My way is the right way. Okay, then x plus 1, x minus 1. That cancels that. And I haven't even started the divide part. Okay, the divide changes into a times, and I flip it. How many of you remember to multiply and flip? Awesome. That's one of those top 20 things. So I hope that that one was pretty intuitive for you. And now, do you see one more thing that can cancel? X minus 1s. So I'm going to cancel out this. 5, sorry, x minus 5s. That one and that one are gone. Final answer, x plus 7 over x minus 1. Changing colors because I can tell on the board it's easier to see the yellow. There's your function. You got any questions on that one? Seem pretty easy? Good? Because it is. So homework for tonight, just do the odds again. Same as last night. Let's start it together. Everybody find the worksheet. And then I'm going to ask in a second if somebody would tell me what problem number 1 says. Okay, number 1, TT, what did you get? Did you find it? Getting close? How about if I come back to you? Do you have it?
Yeah.
Number 1, read away.
So 1 over x minus 4
Yep.
times negative x to the power of 2 plus 9x minus 20 divided by x plus 2.
Okay, awesome. Thank you. Now, I see something right away. I don't know if the teacher's theme on these worksheets is to give them a trick problem on the first problem, but It's actually okay because I oftentimes talk over the first question with you. So, do you see what needs to be factored out that people often don't think of? -1. -1 comes out, and it'll be so much easier to factor after that. It's a really, really good tip. If there's ever a negative lead, factor it out. And then it'll factor further. And if you wanted to save some time, it'd be totally okay to just put it right above it. And then you can cross it out once you got it factored. Did you figure out it had to be an x and an x, and a 5 and a 4? And which one should be negative? Both. Because that makes positive 20, and that's in a negative middle term of -9. Okay, so does everything cancel? No. Does something cancel? Yes. What do you see that cancels? X minus 4 cancels. That and that are gone. Now this is just 1 over, what residue is left behind when you cancel something? A 1. So 1 over 1 is just 1. 1 times anything is just that thing. So then this stuff's all gone. And now I have -1 times x minus 5 all over x plus 2. Should I leave that factored on top? In general, if you can factor it, you should. So there we go. Yes? A negative sign alone or a -1 would do the same thing. So whatever you prefer. Okay. I know it's hard to read, so I'll just write over it to make it a little easier to read. There we go. Okay. So it's just like that, and you have a few problems to practice, and I've been trying to get you ready for when this stuff gets more difficult. But for right now, it's easy street. Now I'm going to hand you tests back. Now, this is a good time to remind you that in this class, you do get a retake, but it's not immediately. So let's say that you did badly on this. There's going to be a couple people that are going to be disappointed. They're going to want to take a blank piece of paper, do corrections, and then if you do the corrections and you get your homework done, you qualify for a retake when we take the cumulative, but it's not going to be for a few weeks. So it kind of sucks. You're going to have a bad score in your grades for a couple weeks if that happened to you. And I know I didn't put them in yet. I kind of like seeing the look on your face when you get your tests back. So it's not just for me to torture you. It's just a time thing. So if I have to be going through them right now, it's very easy for me to just type a number on my thing as I'm going through them, as opposed to at home and be just completely added extra work. So I try to do it in class just to save myself a little bit of time. All right. So I'll hand those back to you. And you work on the homework for today, which is just about multiplying and dividing fraction functions, which we call rational functions, because rational numbers can be written as a fraction.